Mars hangs in our night sky. It is a small red dot of light. For centuries, we have looked at it. We have wondered about it. Is there life on Mars? Could we live there? These are not just questions for stories anymore. They are questions for scientists and engineers. They are questions for all of us. Mars feels like a new shore waiting for our ships. It is a place that pulls on our imagination. It dares us to come and explore. The dream of Mars is becoming a real plan. A plan to send people across space to a new world. Why do we look to Mars? It is not the easiest place to reach, but it is the most familiar place that is not Earth. Mars has a day that is almost the same length as ours. It is just over 24 hours long. This gives it a rhythm we can understand. It has seasons, just like Earth. It has polar ice caps that grow and shrink. It has an atmosphere, though it is very thin. Billions of years ago, Mars may have been much warmer. It may have had rivers, lakes, and oceans. The search for past life is a powerful reason to go. Exploring Mars is also about us. It is about the future of humanity. We have always been explorers. We have crossed oceans. We have climbed mountains. We have even walked on the moon. Going to Mars is the next great step in that journey. It is a challenge that will push our technology to its limits. It will force us to invent new ways of living. Having people on two planets is also a form of insurance. It protects our species from a disaster that could happen on Earth. It is a backup plan for our civilization. This essay will outline the path to Mars. It will not use complex words or confusing ideas. It will use a simple timeline. It will break down the journey into small, clear steps. We will look at the rockets that will take us there. We will explore the homes we will build. We will see how we can find water and grow food. We will face the dangers honestly. The journey is long. The risks are real. But the path is becoming clearer every day. We are closer than ever to leaving our first footprints on the red soil of Mars. Our first explorers on Mars are not human. They are robots. These tough machines are our eyes and our hands on the red planet. They have been working there for decades. Orbiters circle high above Mars. They map the surface in incredible detail. They study the thin Martian atmosphere. They look for signs of water hidden beneath the ground. They act as communication relays. They send back the data from the rovers below. These orbiters have given us a complete picture of the planet. They have shown us where it is safe to land, where the most interesting science is. On the surface, rovers crawl across the dusty plains. They are like robotic geologists. They carry tools to drill into rocks. They have cameras that send back amazing pictures. They have labs inside them to analyze the soil. Missions like the Spirit, Opportunity, Curiosity. They prove that Mars once had liquid water on its surface. The Perseverance rover is even now searching for signs of ancient life. It is also collecting rock samples. Getting to Mars requires a new generation of fully reusable rockets. By reusing them like airplanes, costs drop, making frequent trips possible. Large ships will launch empty and be refueled in orbit, allowing them to carry more cargo. For the return journey, we'll make fuel on Mars itself, using its atmosphere and water ice to create rocket propellant. Once astronauts arrive on Mars, they will need a safe place to live. A Martian habitat is much more than a house. It is a bubble of life in a very harsh environment. It must protect the crew from the extreme cold. It must hold in breathable air at a comfortable pressure. Most importantly, it must shield people from dangerous space radiation. Mars does not have a strong magnetic field or a thick atmosphere like Earth. Our first homes must be fortresses against this invisible threat. The first habitats will likely be sent from Earth ahead of time. They could be inflatable structures, packed small for a rocket, then inflated into large living areas, made of many layers of tough, advanced materials. or rigid modules, like those on the ISS, strong metal cans that can be linked together. No matter the design, these homes will be small, just enough room for sleeping, just enough room for working, just enough room for eating. To protect against radiation, habitats will need extra shielding. Use Martian soil, regolith, as the easiest shielding. A few feet of soil provides excellent protection. Another idea, build underground. Use natural lava tubes or dig tunnels. Underground offers the best radiation protection and moderates temperature swings. Inside, a complex life support system runs constantly. It produces oxygen, removes carbon dioxide, recycles water, and controls climate. These systems exist on the ISS, but on Mars they must be more reliable. There is no quick resupply from Earth if something breaks. Living on Mars means living off the land as much as possible. We cannot rely on supplies from Earth forever. The three most important resources we will need are water, food, and power. We know there is a lot of water on Mars in the form of ice, at the poles and underground. To get water, robots will act like miners. They will dig up the icy soil, heat it, turn ice to vapor, then condense it back into liquid water. This water will be precious for drinking, for growing plants, and for making oxygen to breathe. Every drop will be recycled. For food, the first crews will bring packaged meals from Earth. But fresh food is important for health and morale. So, a Martian farm will be set up quickly. Plants will be grown in special chambers, in regolith-based soil with added nutrients, or hydroponics with roots bathed in nutrient-rich water. Bright, efficient LED lights drive photosynthesis. Early crops, lettuce, radishes, and tomatoes. These plants will also help recycle the air by producing oxygen. All of this technology needs power. Solar panels will be a major source of energy, especially near the Martian equator. The challenge with solar power is dust. Martian dust storms can cover panels and reduce output. Robots will be needed to keep them clean. For a constant, reliable source that works day and night and during dust storms, we will need nuclear power. Small reactors can provide steady electricity for years. This combination will keep the lights on and the life support running. Mars is not a friendly place. Surviving there will be a constant struggle. The biggest health risk is radiation from cosmic rays, as Mars lacks Earth's protective atmosphere. Low gravity weakens muscles and bones. Abrasive dust gets into everything, damaging seals and machinery. And isolation is immense, with long communication delays and no real-time help from home. The journey to Mars is a marathon of logical steps. Robotic preparation will last until 2030, followed by uncrewed cargo missions to deliver habitats and equipment until 2035. This sets the stage for the first crewed mission in the late 2030s. A permanent base could follow in the 2040s, evolving into a true settlement by the 2050s with hundreds of residents.